Well, good morning and welcome to another week. I'm excited to say that we only have 2 days this week and we have the rest of the week off due to Thanksgiving. And I know some of you are extremely excited for a break. Even teachers need breaks sometimes, so we're both kind of excited for that. However, with these 2 days, this lesson that I'm introducing today will last for the next couple weeks. So there will be no new lesson next Monday. We'll just be kind of working through this and actually allowing some of you to have been falling behind to catch up and to continue completing the units as you're completing them. So this lesson might look a little different for some of you, is that it's a reteach. So I'm going back to look at a couple checkpoints that some of you have been struggling with, and the idea that I came up with is this idea of similarity. So this is going to be what we call a reteach lesson. So some of the sections in here might stay the same, the learning target stays the same, but we're going to kind of break it down into a more basic level and help you kind of actually understand what's being said to apply that to your checkpoints. So again, I advise some of you that are, at this point, use this lesson to help you, and those that are not, please continue to work and finish these units, as we're moving through and entering into a new unit here soon. So again, what is similarity? So the learning target for this lesson is I can explain why two transform figures are similar based on two things, sides and angles. So again, sides and angles play a key factor in if something is similar based off those transform figures. So again, the sections in here have the same wordage we've been using all year: engage, explore, explain, and so on. So some of this will change. So the engage section looks a little different, to kind of have you look at a picture and just tell me basically why are they similar or not. The explore section, again, has different resources from the previous lesson that we had. So I'm giving you some additional resources to kind of help you, maybe a little bit more basic resources to get you to understand the idea of similarity. The explain and evaluate sections are a little bit different. The evaluate, I have you complete a different checkpoint, applying angle similarity. And then explain, I have you do a flip grid, just basically giving your own explanation of what similar means from the resources. So it's a little bit more basic thing. Now, the only thing is with this elaborate, I changed it a little bit to apply it to, this lesson. So again, it's you are making correct statements about similar. So you're using your understanding of similarity to look at this document and this real application and give statements that these people are making, and then you come up with your conclusion. Are they making correct statements about similarity? What is their thinking on task? Or maybe, maybe you can share something that you have learned that they should be saying, or maybe they're just using terminology a little bit different than they should be, or maybe they're totally wrong. Maybe you can give them some advice and say, okay, this is what you should be saying, and things like that. So use your understanding of this lesson to kind of help you complete that elaborate. So before we end, I do want to go back and just like we normally do and just kind of look at this resource and kind of see what this idea of similarity is. So most of the time with similarity is we use the idea of a triangle, right? So similar triangles are a big thing, and we use that to kind of help us show how angles and sides are similar. With angles, what we use is these little half circles, all right? And we use them because we can look at these figures and say that every figure that has that single half circle, all right, those are the similar angles of those triangles. No matter how they're flipped, reflected, moved, all right, if we were all make them the same direction, those single lines would be the same for every angle. So those single line ones are all the same angle. The double half circles are all the same angle, and the triple half circles are all the same angle. And they're showing you no matter how they're moved, flipped, enlarged, or anything, they're still similar if the angles are matched up. And these lines that we give show that in these triangles. And again, they call them little arcs. I call them little half circles. You can call them whatever you want to. So again, even if things are flipped, moved, or anything, the angles, as long as the angles stay the same, all right, and as long as the ratio of those angles stay the same, then everything is good. All right. Nothing is being said with similarity is that things are flipped or moved or enlarged, that they're not similar. Yes, they're still similar figures, and the angles can actually stay the same. Okay, so that was my first time pausing a video. We had a fire drill, so if you're watching this video, you get to experience that first fire drill for our school. But yeah, so sorry about that. So again, just kind of reiterating what I said about the angles stay the same, and that's usually when you see these little arcs, they show that the angles are staying the same, even if they're being flipped or moved or rotated or reflected or anything like that. The second thing is that the angle the angle and the sides need to have the same ratio, need to be similar as well. And we've talked about corresponding sides. So again, if it's being flipped or reflected or moved, the sides can still be corresponding even though the shape itself is oriented in a different direction. But what we say is as long as the ratio between the corresponding sides are the same throughout every single side. So if you look at this example, right here. So here we're actually trying to find the ratio. Is the ratio work between all of these numbers? And how we do that is we have to find the corresponding side that's already given. So here we're given 6.4 and 8. Those are corresponding sides. So what we need to do is we can divide 6.4 over 8 to get what we need to find to help us find the other ones, okay? So the ratio between those two things. And we can use that ratio, like here in step 2, to apply that to the other sides that we have. So here we're trying to find what side A would be and what side B would be. So we can use the ratio that we're given, all right, and reducing that down to, a decimal, and using that to see if that works with the other numbers. Now, in this case, we're finding missing lengths, but sometimes we're actually given all the numbers, like in some of your checkpoints, and all you need to do is find the ratio or take the second figure or triangle and divide that by the first figure after you found the corresponding sides, and you'll get what we call a scale factor. I mean, that's what we call it. Is that true? Is that number, that scale factor, is that kind of, you want to say constant, or that number that we're going to use and apply to the other lengths. So once we apply that to, 6 and 7, then we can be able to determine if these two triangles are corresponding. All right. So again, take the number from the second triangle or the second figure and divide it by the first to get that that scale factor number. And then we can apply that by multiplying that to the first triangle lengths to see if they match up with the second. If they're all the same, we say that's similar. If any of them are different, then it's not similar. That means the shape itself was actually, either enlarged or something was moved there, where a length is actually a different length, which would affect the angle. And so again, that would not be similar. Okay, so again, this idea of similarity depends on angle measures and side measures. All right, and we call that, again, that word ratio. Is that the same throughout all the triangle or both figures given? And if so, then we say those things are similar. But the idea is that they do not have to be the same size or the same orientation. They can be moved, they can be enlarged, they can be shrunk, they can be reflected, as long as those sides and angles stay the same. All right, so use this thinking to kind of help yourself, again, through this lesson, and hopefully at the end of this lesson, this reteach lesson, you can confidently say, I can explain why two transformed figures are similar based on their sides and their angles. If you have any questions, please let me know. Continue working hard and work on those units that you're needing work on, and reach out for help if you need to. Thanks.